Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about relative velocity. Relative velocity means relative to other object, what is the velocity of an object? Or with what velocity an object is appear for other object. That we will see here. So we can take some examples. If you are moving in a bus in this direction, okay, this is the bus, in this direction you are moving, there is another bus, it is moving in the same direction, okay, you will feel that this bus is to be at rest. If this bus is to be coming in the opposite direction, you will feel that this bus is moving very fast. And another example, when you are traveling in a train, the train is moving, you will feel that the outside trees are moving. But when the train is rest, you will feel that the outside trees are rest. These are all the phenomena we can explain with the help of relative velocity. So, the rest and motion are relative term. We cannot say that a body is to be purely at rest and purely in motion. That means I consider an example. There is a bus. In this bus, have two persons, A and B. A person, look at from outside, that is the C person. For C person, A is appear as moving. The bus A is moving, bus is moving in this direction. For C person, A is appear as moving with the velocity of the bus. But for B person, A is appear as at rest. So that means what we got? Two different person, one body itself appear as rest and motion. Otherwise I can say that for two different person, one body itself appear as two different velocity. So we have considered the earth is the reference, that is the ground is the reference. All the bodies velocities are measured compared with the ground velocity, and we have taken the ground velocity is 0, that is Vg is equal to 0. Okay, ground velocity is 0. Then if a car is moving on a road with a velocity of 40 km per hour, how much? 40 km per hour. That means the velocity of the car with respect to ground is 40 km per hour. Velocity of the car with respect to ground is 40 km per hour. That means velocity of the car minus velocity of the ground is equal to velocity of the car with respect to ground. Okay. So, based on this, we will discuss different cases. A car A is moving with a velocity Va in this direction. A person was looking out. With what velocity this A is appeared for the person? That is the relative velocity of the A with respect to person. Okay. So, relative velocity of the car A with respect to the person. With this velocity, this car appear for this person. This person is at rest. So velocity of the car A minus velocity of the person. The person is at rest, so its velocity is to be 0. That is equal to velocity of the car. Okay. Then, if another car B car move with the velocity Vp and in the same direction it is moving. There is a person in the B looks A. For B person, A appears that the A is coming towards him. For B person, A is to be appears that A is coming towards him. Okay, with what velocity the A will appear? That is the relative velocity of A with respect to B. I will repeat. A will be appear for B person. A will be appear for B person is the relative velocity of A with respect to B. So now we will see relative velocity of A with respect to B is VAB is equal to VA minus VB. Okay, clear? With this velocity, A will be appear for B person. Okay. If another person was there in A, he is looking B. Okay. For A person, B is appear as B is moving away. For A person, B is appear as B is to be moving away like that appear. With what velocity it will appear? That is the relative velocity of B with respect to A. I will repeat. B is appear for A person is the relative velocity of B with respect to A. So we can write that relative velocity of B with respect to A is VBA is equal to velocity of B minus velocity of A. Okay, this is a case of relative velocity when the two bodies are moving in the same direction. If the B is moving in the opposite direction, what about the relative velocity? A is moving in this direction with the velocity VA and B is moving in this direction with the velocity VB. Okay. From B, one person is looking A. Okay. So for B, what velocity A will be appear? That is the velocity of the A with respect to B. Okay. For A, B is to be coming towards like that it will feel. For B, A is coming towards like that it will feel. Okay. So for B, A is appear as the relative velocity of A with respect to B. Relative velocity of A with respect to B is equal to velocity of A minus VB. Why I am taken here minus? Because B is moving in the opposite direction of A. So you will get as VA plus VB. Okay, this is the relative velocity when the bodies are moving in the opposite direction. Clear? This is about the basics of relative velocity. Now we will see some special cases and position time graph for relative velocity. This is the origin, position x1 of 0, that is a body 1 moving with the velocity v1. Another position x2 of 0, another body 2, this is the first body, this is the second body, the second body is moves with the velocity v2. Okay, this is x2 of 0. At t is equal to 0, the first body is at x1 of 0 and the second body is at x2 of 0. Okay, this is the initial position. So the second body is far distant from the first body. Okay, what is the initial displacement between them? That is x2 of 0 minus x1 of 0. This is the initially distant between them. These two bodies are moving. So after some time their position may change. What is the position of the first body after t time? That is x1 of t is equal to x1 of 0 plus the velocity of v is constant. So v1 into t. This is the position of the first body after t time. The position of the second body after t time is x2 of 0 plus v2 t. Okay, then I want to find out what is the distance between the body after t time. That is x2 of t minus x1 of t. That is equal to x2 of 0 minus x1 of 0 plus v2 minus v1 into t. This is the position of the two bodies. Okay. Now we will see what is the cases in this. First case, I am considering if v1 is equal to v2, that means two bodies are moving with the same velocity. If v1 is equal to v2, what about v2 minus v1? That is equal to 0. So what about this? That is equal to x2 of t minus x1 of t is equal to x2 of 0 minus x1 of 0. That means the distance between the body is to be still constant. Initially, this is the distance. After t time also the same distance. Clear? Okay. This is about the case 1. So based on that we can draw the position diagram for this case. This is x1 of 0. This is x2 of 0. Bodies move like this. So you can see that distance between the bodies always constant. Clear? Okay. Now we will see the case 2. V2 is greater than V1. If V2 is greater than V1, what about this term? This term is a positive value, that is V2 minus V1 become a positive value. If this is to be a positive value, what about this value? This value is to be increases. So the distance between the two bodies increases. That means the second body moves away from the first body. So we can draw the position diagram. This is the position and this is the time. Then x1 of 0 and here is the x2 of 0. Okay. Graph of x1 is like this and x2 is like this. Okay. You can see that is the second body is move faster, so that this body is going away from the first body. Clear? Okay. This is about the case 2. Now we will see case 3. Case 3. Case 3, I am consider if V1 is greater than V2. If V1 is greater than V2, that means the first body is moving faster than the second body. So what about this term? V2 minus V1 is become a negative value. This is a negative value. So you can see that the distance between two bodies will be decreases, and at a particular instant two bodies will meet, and again the body will be continuous, that is A will be goes away from the second body. Clear? Okay, that we will draw in the graph. So if V1 is go faster, the distance between the two body decreases initially. Okay, so this is x1 of 0 and this is x2 of 0. Okay. Okay, now you see that at this point these two bodies are meeting. Okay, this is the time t. At t1 time, the distance between the two bodies to be 0. That means this is the position and this is the time. So that means I can write it like this: x2 of t1 minus x1 of t1 is equal to 0. That is x2 of 0 minus x1 of 0 plus v2 minus v1 into t1 is equal to 0. So from this, what is t1? t1 is equal to x2 of 0 minus x1 of 0 divided by v2 minus v1. That means what you are getting here, what is the initial distance divided by the relative velocity, that is equal to the meeting distance, that is the meeting time. Okay, clear? Then this is about the case 3. Now we will see case 4. Case 4. In the case 4, these two bodies are moving in the opposite direction like that I am considering. That means I am changing the diagram. The first body moves with the velocity v1. This is the origin. Initial position is x1 of 0. This is the second body. Move with the velocity v2 and initial position is x2 of 0. Initial distance is x2 of 0 minus x1 of 0. Clear? Okay. What about this equation? x2 of t minus x1 of t is equal to what you get? That is x2 of 0 minus x1 of 0 plus what about the relative velocity of the second body with respect to first? That is minus v2 minus v1 into t. Why v2 is taken as minus? Because v2, the second body, is moving in the opposite direction of the first body. So this I can write like this: x2 of t minus x1 of t is equal to x1 of 0, sorry, x2 of 0 minus x1 of 0 minus v2 plus v1 into t. v2 plus v1 into t we will get. That is what we can get from this. The distance between the two bodies decreases at a particular instant. These two bodies will meet. So we can draw the position diagram. The position diagram is a position diagram. This is x1 of 0 and this is x2 of 0. Okay, clear? This is the meeting time. This time is I am taken as t2. At the t2 instant, the distance between the two bodies to be 0. So we can find out the t2 time. How we can find out the t2 time? That is at t2 instant, x2 of t2 minus x1 of t2 is equal to 0. That is x2 of 0 minus x1 of 0 minus of v2 minus v1 into t2 is equal to 0. Okay, this is t2. From this, t2 is equal to x2 of 0 minus x1 of 0 divided by v2 plus v1. v2 plus v1 we will get. That means you look at here. Here the denominator is v2 plus v1. Here the denominator is v2 minus v1. So the t2 is smaller than t1. Look at this graph. Okay. So that means when the two bodies are moving in the opposite direction, with a very less time they will be meet together. Okay. This is about the relative velocity.